Hi, welcome to Automotive Appreciation Part 9. In this section we learn about engine lubrication, friction and bearings, oil pumps, oil filters, wet and dry sumps and how to change oil. The lubrication system must deliver clean oil at the correct pressure and temperature to lubricate all parts of the engine. The forced oil system lubricates moving parts, reducing wear, provides a seal, removes heat and reduces power loss. First, we look at the individual components. When there is relative movement between two surfaces, there will be friction and heat is generated, resulting in an energy loss. If we take a closer look at the contact surface, we see peaks and troughs, and the ideal solution is to prevent contact between the two surfaces. If a film of oil is introduced, it will prevent contact and one surface will glide over the other. There will be no direct contact, friction will be dramatically reduced, and it will prevent overheating. The bearings in an engine use hydrodynamic lubrication. There is a very small clearance between the shaft and the bearing journal. When the engine is started, the shaft is running without lubrication for a short period. When oil is introduced, a film of oil is dragged around by the shaft, and the shaft is then centered in the bearing housing. Now we have hydrodynamic lubrication. Here we show an internal gear oil pump. One gear is driven by the engine, and as the teeth separate, they draw oil from the sump and force it through the outlet. This is a positive displacement pump, which means we get a fixed amount of oil flow for each revolution of the pump. We must understand that a pump only creates a flow of oil. Pressure is created when the flow of oil is restricted. We use a Bourdon pressure gauge to indicate oil pressure. When pressure in the tube increases, it tends to straighten, and this change in dimensions is amplified by the linkage and gears and displayed by the pointer on the dial. If we close the valve, the flow of oil is restricted and we start to build pressure. If we close the valve further, we see another increase in pressure. We cannot close the valve fully because this is a positive displacement pump. If the valve is fully closed, pressure will rise sharply and something will break. Usually a pressure relief valve is used to protect against this situation. When the valve is opened, there is no restriction and we lose oil pressure. In this animation we show a lubrication system, two bearings, a pressure gauge, pressure switch, ignition switch, battery, oil warning light and gerotor oil pump. Again, this is a positive displacement pump. For each revolution, a fixed amount of oil is drawn in and forced through the outlet. When the pump is started, there is an oil flow to the bearings. Oil is introduced to the rotating shafts and we have hydrodynamic lubrication. The flow of oil is restricted by the small clearance in the bearing. We have good oil pressure, indicated by pressure gauge in the green area. The pressure switch is open and the oil warning light is off. If there is wear in a bearing, the clearance will increase and there will be less restriction to the flow of oil. This will result in a drop in oil pressure. Without the correct pressure, the oil will not reach the more remote bearings and they will be starved of oil. Now we have low oil pressure on the gauge and the pressure switch has activated, alerting the driver via the oil warning light. If this situation is allowed to continue, friction will cause the bearing to overheat and seize the engine. Note, the low oil pressure was caused by a worn bearing and not due to any issue with the oil pump itself. This is often the case with a high mileage engine. The sump or oil pan provides storage of oil for the system and oil level can be checked with a dipstick. At the end of the pickup tube, a wire mesh strainer protects the inlet to the pump. The oil level must be above the level of the inlet strainer, but not so high that it will foul the rotating crankshaft. The oil pump is mounted low in the engine and driven by the crankshaft or camshaft. The gear pump consists of a pair of meshing gears. The oil pump draws oil from the sump and creates a flow of oil. Again, pressure is only created when the flow of oil is restricted. In an engine, restriction is created by the leakage of oil from the small clearance between the journal and the bearing. If there is excessive pressure in the system, a pressure relief valve will operate, allowing some of the oil to return to the sump. As the oil lubricates the engine, it will pick up dirt particles which are removed by the filter. Early filters consisted of a housing and a replaceable cartridge filter. Later manufacturers introduced spin-on filters, which were easier to fit. However, recently the trend is back to cartridge filters, which are considered to be easier to dispose of. This is a spin-on filter. The housing and filter element must be changed as a unit. The oil from the pump passes from the outside through the filter media towards the centre. A bypass valve ensures an adequate oil supply in the event of a blocked filter or during a cold start with viscous oil. If the spring-loaded valve operates, the oil will bypass the filter. A non-return valve or flap prevents the oil draining back to the sump when the oil pump is stopped and ensures an immediate supply of oil when the engine is started. The pump forces oil through the oil filter to the galleries and passages, which then distribute it to the crankshaft, connecting rod bearings and cylinder wall. Oil is forced through holes in the crankshaft to lubricate the big end bearing. The cylinder is lubricated via spurt holes or oil jets, which coat the wall with a film of oil. The bottom piston oil control ring scrapes excess oil off and ensures the correct film of oil remains on the cylinder wall. Excess oil drains by gravity to the sump. The oil will provide a sliding seal between the piston ring and the cylinder wall. The seal helps maintain cylinder compression during the compression and combustion cycle, preventing blow-by. It will also prevent oil entering the combustion area when the cylinder is under negative pressure during the intake stroke. Oil is also pumped to the camshaft and valve springs. An oil seal at the top of the valve guide prevents the oil from being drawn into the engine. Ideally, there should be an oil mist in the crankcase and around the camshafts. However, we do not want a build-up of combustible gases from blow-by. In the past, the ventilation was vented to atmosphere, but this was considered a source of hydrocarbon emissions. The PCV positive crankcase ventilation system routes combustible gases to the intake manifold where they are burned, thus reducing emissions and preventing overpressurizing of the engine. When the oil has completed its work, it drains by gravity back to the sump where the heat is dissipated to the surrounding air. Any metal particles in the oil will be deposited at the bottom of the sump where they will be attracted to the magnetic drain plug. Most engine wear occurs on a cold start because there is no oil film between the bearing and the shaft. On starting, the oil is cold with high viscosity and takes some time to reach the bearings. When we build oil pressure, the warning light is extinguished. Some engine control systems limit engine speed until the oil is up to operating temperature. If the oil is not changed at the recommended interval, its viscosity can change. Oil pressure is lowest when a hot engine is allowed to idle. An abnormally low oil pressure usually indicates a worn engine, as leakage from the bearing clearance is faster than the pump delivery rate. However, it could also be a low oil level, a failed pump, faulty pressure switch, or a blocked filter. As manufacturers strive to improve efficiency and economy, it places a more onerous task on the lubricating system. Engines run at higher temperatures utilizing the minimum amount of lubrication oil. The characteristics of the oil are improved with additives which inhibited corrosion, reduce foaming, reduce oxidation, and act as a detergent. Modern engines use low viscosity synthetic oil as the clearances in the bearing have been reduced and less energy is required to pump. The oil must fulfill other tasks, such as hydraulic oil for the cam timing advanced system and hydraulic tappets. The grade and viscosity must be suitable for the engine design and operating conditions. Because a vintage car has 300,000 miles and has used a certain type of oil, it does not mean that the same oil will be suitable for a modern high-efficient engine. Likewise, an expensive, fully synthetic, low-viscosity oil will not be suitable for a vintage car. When we refer to viscosity, we mean the oil's resistance to flow. It is determined by the SAE number. A low number means a thin oil, while a high number indicates a thick oil. A W indicates the viscosity at a cold temperature, while the standard resistance is measured at engine operating temperature. In this example, the oil has an SAE viscosity of 5 at reduced temperature and flows like an SAE 30 at normal operating temperature. So far we have described a wet sump which is used on most road cars. The sump is located at the bottom of the engine, the design is simple, and the oil is stored close to where it is needed. Some cars, such as high-performance cars, have a dry sump which has an external reservoir which is not located under the engine. The engine can be moved down, providing a lower centre of gravity. Oil is kept away from the rotating crankshaft, and the sump itself can be any shape or size. An additional oil cooler can be used which operates similar to the water cooling radiator and prevents the oil from overheating. On modern cars, electronic analog measurements are used to monitor oil pressure and level. Oil quality can also be monitored, and the engine control unit alerts the driver when an oil change is due. Before changing oil, we run the engine for a short period to warm the oil. A container is placed under the sump, the filler cap is removed, and we open the drain plug. While the oil is draining, the oil filter is replaced. This is a cartridge filter which is contained in a removable housing. It's sometimes called an eco-filter, as only the element is changed, saving on material and disposal costs. When the filter housing is unscrewed, a hole opens in the housing and allows the oil in the filter to drain internally to the sump. The element contains no metal parts, it's manufactured from paper and plastics, and is suitable for incineration, capturing heat from the waste oil. The new filter and O-rings are fitted and the housing is tightened to the correct torque. Dispose of the old oil in an environmentally friendly manner and tighten the drain plug. The sump is now filled slowly with new oil to the desired level. When the oil is allowed to settle, the level can be checked with a dipstick. The level should be at or just under the high level mark. Fit the oil cap and clean any oil spills. When the engine is started, it will fill the filter with oil. Check the oil level and again, be careful not to overfill.